Hello everyone. Today I'm going to present our project called Nest of Light, a pavilion developed as part of our construction materials and procedures course. The main goal of this project was to create a simulation model using versatile materials in order to better understand how construction processes are applied in real architectural design. Our concept focuses on the idea of how technique and aesthetic can work together. The pavilion uses brise-soleil walls as a kind of second skin. These elements filter natural light, creating a changing pattern throughout the day and showing how structure and visual design can complement one another. The inspiration comes from the Hanover Expo Pavilion from the year 2000, which also explored light, rhythm, and materiality. Before starting the model, we carried out a site analysis and developed architectural drawings, including plans, elevation, and structural layouts. These drawings helped us understand the exact location of the wood poles, wedges, beams, and stringers that would later form the structure of our model. For the construction of our simulation model, we used simple materials such as balsa wood, MDF, cardboard, battery paper, pins, and basic tools like knives and hammers. Even though these materials are lightweight, they allowed us to accurately represent the behavior of real construction elements. The construction process was divided into several stages. First, we assembled the shoring, wedges, and bracing. This step was surprisingly long and required a lot of patience, especially because the 1:50 scale made the work more delicate. Leveling the formwork correctly was one of the biggest challenges, but it was essential for the stability of the model. Next, we positioned the poles on the ground and installed the main beams and stringers. Once the braces were correctly placed, the leveling process became easier. We later added top bracing to reinforce the structure and guarantee that the plywood sheets would sit properly. After completing the lower section, we moved on to the second part, the design and assembly of the trusses. Through trial and error, we determined that triangular trusses would be the best solution. These trusses use a system of internal triangles, which allowed us to reduce the size of the structural pieces while maintaining strength. We also created intentional empty spaces in the design to make assembly easier. One of the most challenging steps was the installation of the ceiling. At first, we didn't have a clear reference for a ceiling design that matched our pavilion. With guidance from our professor, Elizabeth Kittel, we reviewed different examples of ceilings and wainscotings, finally choosing a simple and clean design that fit the concept of the project. Once all components were assembled, we achieved our final pavilion model. From this process, we learned several important technical lessons. We confirmed that scale is fundamental for the representation of real proportions and understanding construction systems. We also learned that bracing is essential for transferring loads safely throughout the structure. But most importantly, building the model helped us understand real construction methods in a practical and hands-on way. Finally, and based on what we learned, we developed some technical recommendations for students in the future. First of all, we suggest that you improve the precision of cutting angles to avoid misalignment while you're joining your pieces. And we also recommend that you create a template to ensure that all the slot pieces share the same angle. That'll be it for this project. Thank you very much for your time.